All right, good evening, everyone. Welcome to 3342. All right. And today we should do two things. And the first thing is most important. We're going to go over the course syllabus, which is already ready on the website. I'll show you where you can download it. And we're going to go over the policy of the course and make sure I answer all the questions you might have related to how we're going to run for the course for the next 13 weeks. It is so important. If time permits, I might cover a little bit of like an introduction to why we're doing this course in the bigger context of professional engineering. I'll give you some context. So today is going to be pretty light, but it's mainly to make sure you understand how to do well for the rest of the course. Right? That'll be the goal. And if there's any question you want to interrupt me, don't worry, I don't mind. Just raise your hand or just speak up. Let's go over some slides, and then I will also go to the syllabus in a moment. All right, for those of you who don't know me, most prefer just call me Jackie. That's completely fine. I'm quite informal. There's no need to be formal when you address me. That's okay. If you want me to call me Professor, Professor Jackie, Professor Waynes, or more informal, Sir, hey, hi, that's also fine. Whatever you like, okay? And whenever you need any advice on how to perform maybe better in the course, speak to me sooner rather than later. I think as you will see, starting from next week, we'll get quite technical, a little bit mathematical about this course. This course is actually a very interesting one. It's a very nice marriage between math and system development. It's not really coding for this course. However, the knowledge that we learn about abstract thinking in this course is going to help you on the coding as well. That's something you can expect maybe at the end. But I'll explain how. And then there will be a bonus opportunity to fill out some course evaluation, midterm course survey. But that's something I will announce a little bit later. Okay. Also, for the final course evaluation, I will also give you guys some opportunity as well, if we got enough response. All right. And throughout the course, if you got any suggestion about how I can make your learning more efficient, let me know. I teach in the way I believe that's good for students, but if you believe there's a better way, please let me know. Except saying the exam should be easier. Except for that. Other than that, I can do. All right. Maybe you will say that anyway. All right, if you're not enrolled yet in the course, please send me your name, student number, and passport your ID so I can add you to the E-class so you don't miss any important announcement, okay, if you haven't. And at the same time, please assume you're going to get into the course optimally so you can still keep up with the lecture materials, also the labs. Make sure you submit them by the deadline. There will be no extension for if you say I get late in enrolling in the course. That will be not acceptable excuse. And the class protocol. So please just minimize the talking and the use of your mobile phone. From my perspective, from my view over here, it's a little bit distracting to me. So please, just minimize that. If you really have to do it, keep it short. That'll be much appreciated. And the slides will be quite self-contained, almost like a textbook. I really try to craft the slide in a very detailed manner, so you can definitely get a lot from there. So in the lecture, since you can't come all the way to commute to the campus, I want to give you something slightly different. So I will still follow the slides as a guidance, but I also got a lot of examples ready on my iPad. So I'll go over an example with you as if like a whiteboard. So we can definitely talk about stuff. So make sure you get you kind of understand. So I will try to make a balance between slides and notes. Yeah, I'll focus on the core example, and then your engagement is really the key. So please feel free to ask questions to slow me down. Otherwise, I might just keep going. Or the other way, if you think I'm going too slow, also let me know. That could be a tendency of mine too. And to email me, as I said, I'm quite informal. You don't need to really address me formally. But I think just some courtesy will be very appreciated. Right? Just be a little bit polite. That'll be very nice. Just don't be too rude. Just give you some example here. You can read them. And when you write me an email, please follow. That'll be very much appreciated. All right, course information. There's only a single section for this course, so very simple. There's only a single E-class site, which you already have received about your lab number 1 instruction. That's good. Let me just go to that site. I want to show you something you can expect, which will be important. So 3342, section E. Over here, So there is an announcement section, but you just get email notification anyway. So you don't need to worry too much. And for study materials, you will see this is a lecture site, which I'm going to show you how to get there. All the slides, lecture recordings, and iPad notes, any example code, or any example proofs, I'm going to post it on the study site. That one has no login required. So you can just go there on a daily basis or even hourly basis if you want to. And for the textbook, I wouldn't say there's really a required textbook for this semester. So for this course, the slides, which I'm going to go over, especially when we get to the case study for the bridge controller, maybe starting from week number 4-ish, that one is heavily based on this textbook, which is called Modeling in Event B. So we got the agreement or permission from the book author. They kind of let our students who, of course, enroll in this course to really get access to a draft of the book. So I would say if you want to find out more case studies, you want to find a little bit more detailed story about the case study we do or math, you can definitely refer to this draft. But just don't distribute it, please. That's a confidentiality issue. And after all, this is draft. Let's say if after this course, you find yourself very passionate about the mathematical reasoning or application to system developments, you can feel free to purchase a book that might be a little bit more polished version than the draft. The choice is up to you. So do you need to buy the textbook other than the draft for this course? No. All right? I want to make it clear. If you study my slides, come to the lecture, do the exercises, you should be fine. And the lab instruction will be made under the lab instruction over here. You already got lab 1. And for resources, for now, I just got some tips over here for you. They were written by the formal students if you need it. Okay? That will be it. And I think later on you can expect when you come for the test, which I'll explain a little bit later, one kind of test called written test, which is based on E-class, multiple choice based primarily, and it's going to be also hosted on the E-class. You got to come to physically in the lab and take the quizzes or the test over the E-class. You can think about, in principle, at least 1 week before your scheduled test. I'll give you some PDF detailing what's the coverage and how you're supposed to prepare. So you don't need to worry. You got at least 1 week to really concentrate on preparing for the test. That should be good enough. If this is not a test, just make sure you also review the lecture materials, do the labs, do your part of the work. All right, let me go back here. And we got announcement, reference textbook. I talked about lab exercises, written test. Okay. And check your email regularly, just for announcement. So whenever the lecture recording or the slides are there on the study site, I'll send you an announcement just to remind you. So if you want to review maybe some parts you don't really get from the yesterday's class or last week's class, you can always do that. That's why I'm recording the lecture for you. Okay, that's the main purpose. And what's required then? Well, whatever I post on this particular site. All right, let's now take a look. Okay, don't memorize the link. If you want to bookmark it, you can do that. But how do you find it? Very easy. Search me, Jackie, EECS, YOKU, for example. And first hit. All right, go to my departmental homepage. Go under lectures. And then you will see that this semester I'm teaching 2030 and 3342. Click on that. And that's where you should really go to on a daily basis to get the study materials. Okay? When I say the lecture materials or like a recording is ready, you can always find that there's a link over here for YouTube icon here. I post a lecture over there on my YouTube channel, so you can definitely refer to it. Okay? Let's take a look here. So I got my office here. That's my on-campus office. I'll mention the office hour when I go over the syllabus. But I will get in-person office hour, which will be in Lausanne Building 2043. I will also offer some Zoom office hour on Monday as well. I will announce the time, so you can also refer to it. Yes? The link is not working? You mean this one here? Oh, okay. Maybe I haven't I'll make sure I upload it after today. Yeah, sorry about that. Yeah. We may only get to, I'll try to see how much we can get to but it's only introduction, not technical. And starting from next week, we're going to do some math review on predicate logic, propositional logic, set theory, functions relations, and I'll make sure I post a slide earlier. So you guys, if you want to do some pre-study, you can feel free. I'll make sure I post them. Sorry about that. That one's not active just yet. But I can see other things, for example, course syllabus, it's there. Okay, I would say that one is pretty much already the final version. Universities still allow the instructor to make any changes they might consider needed until September 18th. I will let you know if I really change anything that's different from what we said today. I'll let you know explicitly. Okay, but beyond September 18th, the only thing that might change, maybe I would say, maybe the due dates for your lab might be slightly delayed because you might need a little bit more time for the current lab, for example. Okay? Other than that, grading scheme, beyond this day, it's not going to change. I'll get to the syllabus in just a moment. Okay? Let me just talk about other things. And there's another document here called semester calendar, which I will also go over. That one there really details about the different milestones for the course throughout the semester, like a scheduled test, and when the lab is going to be supposed to be released, and then which lecture we are, so you can figure out roughly what the coverage might be for the coming test, etc. Okay? I'll also go over with you some detail, but at least you know where to find them. Okay, that's about it. And then for those, it's only optional. If you want to use GitHub, you don't know how to use it, feel free to refer to the tutorial. That one there was kind of recorded a few years ago. There might be some inconsistency since GitHub changed their policy. But if you really got trouble figuring out details, let me know. I'll try to see if I can help. All right, let me go back to slides. Yeah, just a little bit of message over here. So that although it's really my attempt to record every lecture here, so please don't abuse this attempt. So not meant to be a replacement for classes. I would really love to see every one of you to come to class, try to engage with the discussion. That would be very nice. And the idea would be, when you, especially for 3342, the stuff that we're going to address is going to be quite tricky, quite sophisticated. It requires a lot of thinking, a lot of reasoning, a lot of drawing, to really visualize how things work. So the first time you come to the lecture, you might not get, for example, 90%. If you can understand 90% every time, I would say that's pretty amazing. You're basically following everything. But even 80% is good. Even 50% may not be too bad. But what about the remaining 50% that you don't get? That's where the lecture recording can become handy. You can always go back to the previous lecture recording and see those parts you don't really get and try to catch up. That's really the intention. But I don't want to say, don't come to lecture, just watch the recording. That's a different way of learning. We're already off the COVID period. It's not online learning anymore. So anyway. Ask questions, and usually whenever I hear any good question, I'll try to rephrase them and I will answer them. Everything will be recorded, so you can also benefit from that when you study for the recording if necessary. And you're encouraged to take some notes. It's part of the active learning, even though the notes might be incomplete. One thing I will kind of discourage you to do is this. Whenever, if I'm showing some slides with lots of bullet points, it's not so necessary for you to copy the bullet points because things will be made available to you anyway. So you don't really need to distract yourself by copying the bullet points that's already made available to you. What you really want to take notes would be, sometimes I might say something which I don't really write down. That might be something you want to copy down. Especially if I say something that doesn't really make sense to you. Write it down, come to my office hour and say, Jackie, I don't get this. Explain. And then I'll do that. Okay, that will be something I will advise you do that. But most of the stuff I talk about, if I don't think you guys really feel comfortable, I'll try to write them down most of the time. All right, and final message. It will be your call to either make use of the lecture recording and try to review the stuff that you don't really get, or if you just want to use it as an excuse to skip classes, that'll be your call. Okay, hopefully you will choose the former. I really hope. Okay, guys, any question so far? Good. Get to syllabus very soon. Okay. Let's now go over the syllabus, and you can already download it from the study site. Okay, let me now switch to iPad, and let's now do it, page by page. Sorry. Okay, good. Okay, so let's now go over section by section. So about the lab policy, I think this is a snapshot I included in my earlier message yesterday, right, when I released Lab 1. So this one here, very straightforward. Basically, every lab, as long as you submit your best attempt on the lab, your own work, maybe before the submission deadline, you will guarantee to get 100%. It's more like a participation mark, but just make sure don't miss the deadline. I put the deadline to be every the submission deadline will always be a Friday, 12 noon. Again, not midnight. I cannot stress that enough. 12 noon, around lunchtime. Okay? And your lab is not going to be graded, but I will give you detailed solution. You can compare your answer with the solution answer. If you really find that your solution should work, you can ask the TA, or you can come to me and ask myself. For your lab session, I was there yesterday. It's good to see so many of you yesterday. Unfortunately, there's some conflict with one of the committee meetings I'm involved with your lab time, completely overlap. So there will be a few weeks I cannot show up. However, there will be some very good TA. They will be there, so you can always ask them questions. One of the TAs, he completed this course around 2019, and they received a very good grade. So they are also a very good person for you to ask questions about that course material. But I'll try to be there as much as I can to also help you. All right? Yeah, don't really feel really, on the one hand, you don't want to feel obligated to come to the lab session for Q&A. On the other hand, you just come, if you got any doubts, right? You want to resolve them earlier rather than later. Do you guys have any confusion about how the labs is going to work? Anything you think that's unclear? Okay, that's awesome. Yeah, lab number 1 is just to get you started with the rodent and review some basic math, a little bit, like application. For your lab number 2, we're actually going to give you the chance to solve some problem. Okay, that's something we'll see. And the format for your lab test, the programming test, which I'll mention the dates, for your programming test, the format is going to be very similar to lab number 2 and 3. But that's something I will elaborate a little bit more when we get closer to the dates. And of course, for each test, you're going to take individual work. You will invigilate the test. And just watch out here. But this one I just mentioned that. For you guys session, it's kind of back to back. So please just make sure, for example, if you happen to be taking the test in the earlier section, after you finish your test, please don't talk to your friend who's going to take the test later about the test. It's considered cheating. All right, so please just don't do that. But of course, once the test is concluded for the later session, you guys can talk. That's no problem. Okay, just be a little bit more sensitive to this. And for your lab, just always follow the deadline to get the full marks for your labs. And for late enrollment, reach out to me as soon as you can. I'll add you to the E-class. Okay. Any question about the course policy? Just one page, right? Just make sure you understand them. All right. And by the way, it's kind of embarrassing time, right? 5:30 to 7. If you really feel the need to eat your dinner, I don't quite mind myself, right? Just make sure it's not too smelly. That might disturb others. Okay. Other than that, no problem if you want to eat. Question? Yeah, exactly. Yeah, so the question was, are you going to get any practice question for each test? Yes. So I think for, at least for the written test, like a multiple choice based questions, I will give you some example question for sure. For the programming test, that one I'm not exactly sure. I gotta decide. Maybe because mostly they're gonna be very similar level of difficulty to your lab. So it might be just enough to make sure you review a lab. That might be just enough. Okay, I'll see. Okay, but for written test for sure, that one I can say yes. All right, prerequisite. A very important one is please make sure you took 1090. That's important. Okay, maybe in 1090, I guess the way you learn it may just by a very purely mathematical approach. You don't really see much application of math into system development. In this course, we'll show you some possibility of doing that. And when you go to the CLO of this course, maybe next term, 4315, mission critical system, We are following basically the same thing about applying mathematical techniques into system verification, but with a slightly different technique. For this course, we take an approach, something called theorem proving. We are proving theorems. In 4315, the sequel course, they do something called model checking, slightly different. Okay, I'll try to maybe explain to you the difference, maybe a little bit later. For now, I just mentioned the name. All right, for myself, I already introduced myself, and now for office hour. So it'll be Tuesday, Thursday, and also Monday. For Monday, it's going to be over Zoom, 3 to 4 p.m. For Tuesday, Thursday, starting from next week, it's going to be 3 to 4 p.m. as well. Okay, but if you want to see me more, or you want to have an alternative time, you can send me an email. We can try to set up some appointments if you need it, either Zoom or in person. Okay. In principle, I will be on campus Tuesday, Wednesday, Thursday. Monday, Friday, usually I'm not really on campus, but you can definitely ask me, and then we might be able to schedule some Zoom if only Monday and Friday work for you. Okay, we'll see. Just reach out. And the venue, you should have no trouble with it, right? It's just in the, this venue here for the labs are going to be where we have your test, not in the lecture place, not here, in Lausanne building. Okay, I already mentioned the E-class site and study materials, which will be the lecture site over here, right? And also the draft of the textbook over here. Right? Everything has been covered already. And what about available help? My office hour, the scheduled labs, if there is not a scheduled test on the day, the scheduled lab attendance will be optional. You can come to either one or both of the sessions, or you can skip it. It's up to you. But it's really there to have good TA, myself, to answer your questions. So take advantage of that if you need it. And there will be certain lab, 1 or 2, I forgot, but we can look at the calendar in a moment. There will be a certain lab that has no scheduled lab allocated for it because we got some scheduled test. So what I will do instead is to have the TA hold some Zoom office hour for you. So you can still connect to them and ask questions about the lab. Right? You still get the help you deserve. So we are going to leave you alone. We are not going to leave you alone. All right, course description here, right? You can feel free to read it, but that's basically what we're going to do, especially something called Event B. This will be the formalism we're going to learn about in this course, okay? But what's really Event B? You can study Lab 1, and then I'll give you more idea when we get to talk about the case study after the math review. For the course learning outcomes, we can take a quick look. Some items I can just briefly highlight what we're going to do for this course quickly. Okay? So we want to document the requirements, which is pretty much what you were given in lab number 1. You're given some informal description about what I want. You can think of me as a customer. I want you to do something for me, right? That's the requirements. And usually requirements might be organized into environmental constraint and functional property. Do you guys remember what I mentioned, what I referred to them in the document? E description, R description, right? If it doesn't sound right to you, you may want to start your lab 1 soon, all right? E description and also R description, right? That would be something you will also be given maybe in the programming test as well. So given the E, given the R, do something about it, right? So we're going to construct high-level abstract mathematical models of a system. So you still got to declare some variables, some axioms, some theorems, some events. An event has maybe guards, actions, and we're going to generate some proof obligation to prove them. That's basically what we're going to do. But don't worry, I'm going to introduce to you each one of them one by one. Set theory and predicate logic. Just a little test. Do you remember what this is? Oh, sorry, I should draw better. Sorry, that could be my bad. How about this? Belongs to set membership, right? Another simple one. How about, what's the difference between this versus this? Yeah, you're getting, proper subset and subset, right? It will be reviewed, don't worry. Okay, how about one more, okay? Do you guys know this versus this versus this? Oh my God, looks so similar, right? By the way, they are not the same, right? Yes, please. Okay, interesting. Okay, yeah. How about this? I may want to clarify. I know in some math course they use a single arrow like it implies, but for this course, this will be implies, double, like a double arrow, double line arrow. Okay. But these three mean something different, but very related to each other. Okay. Yes, please. Oh yeah, double, no, not implication. Again, implication will be just like a double implication will be this, like an equal sign. Yeah, that's something I'll keep emphasizing. I can see the slight confusion here. No, no worries. Okay. How about I'll tell you the answer? Oh, good. Go ahead. Therefore, no, not that. Not quite. Good try. All right. How about this, guys? Relation, total function, partial function. Can you please tell me, at least you have heard of it? Maybe? If no, okay, don't worry. We're going to review it next week and make sure you learn it. It's required for this course. If you haven't learned it, I don't blame you. I blame your professor from before. How about that? I don't blame you. It's not your fault. But if you don't know it by the end of week number 3, it will be your fault. How about that? Okay. Don't worry, we're going to review it. Okay, so we're going to use the model to reason about and predict the safety of progress property. Yeah. The only thing I want to mention is there is a very important keyword for this course, something called invariance. You guys may have heard about a term called loop invariance, maybe in 3101, I'm pretty sure, right? Can you tell me what loop invariance really is in layman's term? What's loop invariance?
Something that doesn't change.
I agree. Especially in the context of loop, you're saying between iterations, this Boolean condition always holds true. Invariant is actually a very general idea, and we apply this idea to the context of system developments in the sense that there should be certain property that should always hold true on your system. For example, let's say we're talking about nuclear reactor. What would be one possible invariance? For example, the reactor temperature should always be less than or equal to some threshold. That would be an invariant. And invariant is actually a very important concept whenever you want to do verification. If I want to verify if my safety critical system is really correct, what are the invariant properties to prove true? All right, just to mention that, but we're going to dive deep into it. Don't worry. And another very important concept is something called refinements. Okay? For now, you don't need to worry about what that really means in the context of this course. What about just in English? Guys, what does a refinement really mean? Do you guys know, at least? What does a refinement mean? If I say A refines B, what does it really mean? Go ahead. Sorry? Think again, no worries. If I say, in general, I'm talking about English. If I say A refines B, what does it really mean?
When I think of refine, I just think of clearing up or...
Clearing up, yes. In some way, you're making something better. Agree? Yes. I'm just talking about just informal definition. I'm not even talking about math. Because if we want to talk about what refinement really means in mathematical sense, we need some formal definition. But that's not the point for today. Yes, go ahead.
An improvement.
I like the word improvement. All right. So for now, I would say it will be very good if you can remember this definition. When I say A refines B, I really meant A improves upon B. And when we talk about system developments, we can formalize what we really mean by improving upon. So in order for you to review, let's say later for the exam, you really want to kind of struggle to understand why do we have so many refinement steps. Just remember, we're trying to improve your system model bit by bit. That's what we call refinements. It's a very mathematically sound way to do system development. You start with something very simple, gradually improve it to something very sophisticated. And you make sure every improvement is mathematically provable. That's all I would say for now, but we're going to get into detail later. And, okay, refines, we got to do some proofs. Well, don't worry, we'll get there. Okay, sequential, concurrent, embedded. We're going to do mainly these two. Not too much time for embedded. But once you learn about the principle, and if you're really interested in the subjects, feel free to dive into the textbook. That'll be your choice. Yeah, practical tool, yes. Do you remember the name for the tool? Rodent. Okay, that's a tool for this course. Okay. Yeah, for CLO number 9, not too sure if I will get there, but we'll see. If time permits, we'll get there. If not, we can leave it. Okay. But I think from CLO number 1 to number 8, you're going to gain a lot in terms of your understanding about how to apply what you already learned in 1090 or 1019 into system developments. That's really what a software engineer should know, to think abstractly and mathematically. All right, let me go back to the syllabus. Okay, we talk about CLO. I think that's really good. It's good to set the tone for the course in day 1, so you know what you can expect. Grading scheme, okay? I'm pretty sure you're looking forward to it. Let's take a look. Okay. So we got 5 labs for you, including lab number 1, 2% each. You can get the 10% as long as you submit the lab by the deadline. Again, noon, not midnight. Please don't get it wrong. And you will get 2, I said, programming tests in quote. You're basically going to give some problem, and then you're going to solve the problem in Rodent, basically, and then submit the exported projects, and then submit for grading. And then we're going to have some TA to manually read your answer, and then to give you some marks. That'll be 10% each, so that'll be 20%. All right. And then we got 2 written tests. As I said, it will be based on E-class and multiple choice primarily. But you might be given some, not so many, but there might be some question where you'll be expected to type some written answer from the keyboard, maybe. Okay? And 10% each, so that'll be 20% for the written test. The remaining mark will be the 50% for the exam. It's a cumulative exam. Let me go a little bit further. You can ask me a question. So the reason that I want to make the exam cumulative and also very substantial is because that's really the place where I want to see how well you can synthesize all the topics that we cover throughout the term and apply that in a single context, in the exam. So you will be asked questions, drawn from various places throughout the term, not just maybe from where we cover from midterm number 2 until the end. Not really partial, it's total coverage. So how do you do that well? You really want to make sure you continually synthesize all the topics, right? So let's say once we cover the math review, you learn about everything about set theory, predicate logic. As soon as we get to applying these stuff into what we call bridge controller for the case study, for system specification. In that way, you should always go back to the math and see how they can be applied to the system. Right? You should always try to reflect about why things work and why things don't work, especially for math. If I tell you that solution number 1 is going to work, let's say for proving a theorem, you should always think about, is there any solution number 2? If there is it really valid? If it is not, why is it not valid? Things like that. Okay. Yeah, so for the exam, I'll try to give you guys some tips later, maybe when we get closer to the exam. But it's going to be a paper exam. It's going to be 3 hours. I will request maybe a place for us to stay on campus from the registrar office. It will be sometime between December 5th and 20th. Okay? We'll see. If that's early, that's good. We can get it out of the way. If that's kind of late, in December, in summer, that could be advantage. You can take a little bit more time to study. And I can also run some maybe exam review session together with you just to answer your question. We'll see which way it might go. All right, guys, that's the grading scheme. Anything that's not clear to you, please. Everything's good? All right. Okay, so about the letter grades, I think we're still following the old scheme where we got, A plus, A, B plus, B. The new scheme like a B minus, C minus, I don't think we have it yet. So I believe this term we're still running the old system, just to let you know. Okay? If you're curious about it, you can click on the link over here. It shows you 2024, 25. Okay? How do we calculate your roll marks? That one, I'm not going to bother you with the detail. You're basically going to be given some roll marks, which may not be out of 100. It could be 120, could be 150, whatever. We're going to use that percentage to calculate how much you got for that particular component. Very standard calculation, no magic here. You can take a look at this example here. If you don't get it, let me know. I'll explain it to you. But for now, I'll let you read it. Okay? What about the expected weekly workload? Also, it's very standard. I'm just following what Lassang advised. Sorry about that. It should be, whoops. There we go. Here. So Lassang recommends for every credit, there should be 3 to 4.5 hours of study. Right? For this course, if you do the math, 9 to 13.5. Right? Just a very rough division. So 3 hours of lecture, you should really attend. But for the scheduled lab, if this is not a test, and also for office hour, they're all optional. So choose what you need. And the rest will be something between 6 and 10.5. You can use them to complete your lab. You can also study for the lectures and the test, right? Since you want to also prepare for the ultimate exam, which is going to be the most substantial component for you. You can just keep some steady study. And we can also argue this course here is actually quite foundational. In the sense that it can really train you how to think abstractly using the mathematical stuff you learned before. And now you do see some practical application of the math, not just doing some proofs on the paper. Well, we'll still do proofs on the paper, but now we do have some target system to prove against. That's the difference. All right, so a little bit more policy here. If you somehow have to miss a scheduled test for maybe for some valid reason, maybe you didn't feel so well, then you should take a rest, or you have some family emergency, whatever reason. So you should really try to prepare if there's any supporting documents and visit my office hour within a week after the test, within a week, right? Not past. And then we'll talk about maybe some accommodation for your situation. Right? We'll see what we can do to accommodate. And if you're registered with the university's accessibility office, for example, for extra time, please reach out to me and then we can talk about what's going to happen. Because I think for our written test and programming test, we do need some special setup for the test. So it will be the best if you take also in some EECS lab, so we can talk about how to arrange it. Please get in touch with me and we'll talk about it. Guys, any questions so far? We're good? Yes. Oh, the test will be in lab time. Schedule lab. Oh, okay. So this is the thing, right? So, okay, let me say that. So when we actually do Q&A on the non-test day, it doesn't matter which lab session you go to. But when we have a test, you must go to the session you're enrolled in. If you really find a conflict for the current session you're in, you should really try to switch. Keep switching.
You can't make it either.
What if you cannot make it?
You can't make it either. What if we can't go to any of them?
You cannot go to any of them?
No. I want to call up right now.
Oh, you know what? That's something I cannot beyond my control because when you sign up for the course, right? You kind of commit. You're gonna, yeah, But how about this? I would say, try to see which this back-to-back, right? Either 1:30 or 2:30. Look at which time might be the best for you. You have to make some prior arrangement because I announced all the 4 test dates already today, so you can make some prior arrangement with your employer and say you have to come to the campus for a test. So which one is better for you? And make sure you're enrolled in that session. Okay.
Thank you.
No problem. Okay. Question? Good. Alrighty. All right, something exciting for you. Something I think you'll be thrilled. Attending classes not only is fun, rewarding, you can also get some bonus. Oh, that's good, right? So now, I really want to encourage everybody to come. So, I'm going to use something called iClicker. I'm not sure if you use it for other courses, but it's a very easy to install app on your mobile device. And we're going to do some tests. Maybe, oh, sorry, I didn't say test. That might scare you. We're going to do some testing on how to use an iClicker, maybe next week, okay? Basically, I'm going to basically take some attendance for a number of times throughout the semester. Let's say, for example, I might decide to take the attendance every time. I might decide to take the attendance maybe every other week, etc. And then, if for those classes I take attendance, if you are here for 90% or more of the time, you will get 5% bonus on your final grade. So for example, if you only get A, let's say, you get A+. If you only get, hopefully not, you will, let's say if you get, let's say E, you'll be promoted to D. Something like that. Almost like a one-letter grade. But of course, if you got F, you can only get promoted to E. Doesn't help too much, but just do better. Okay. That's the idea for rewarding your come to class. Just come to class and then listen to the lecture and then have some fun. You can read through the detailed policy over here. Okay, I'm not going to bother you too much. It's kind of boring, but just understand how it's going to be set out. However, I would just like to mention a few points just to mention to you. You can see, for example, here, in order to get 5% bonus, you can miss about 10% of the classes. So that gap already accommodates for, let's say, sometimes you have to miss the class for some reason. Maybe you didn't feel well, maybe you just have to miss it. That's okay. I understand that. 10%. So that means I don't really accept any attendance taking to say, oh, sorry, I missed the class yesterday because of blah, blah, blah. Can my attendance be counted even though I passed the time? No. As long as you don't miss more than 10% of the class, you still get 5% bonus, right? So in some ways, it's like a bonus thing over here. It's not penalty. So we don't really, try to, look into the reason why you actually missed the class. Okay, just make it clear. Another thing, I hope none of you will do that to me. Here, I want to say here. If you actually somehow just wait for me to take the attendance, and then once I'm done, you just leave. Doesn't appear so nice to me. So I reserve the right to cancel your bonus if you do that to me. Okay, please don't do that. It's not so nice. Now that you're already here, why don't you stay in the class to learn? I think that's nice to do that, right? But there are only exceptional cases here I'm mentioning, so may not apply to you. But it's good to be aware. So what should you do for setting this up? Please read through over here. You're going to download iClicker. You can follow this guy over here. You can click on that. It's a URL. And please make sure you supply your student number, because at the end of the semester, I'm going to run some script to really record your attendance. It depends on your student number. Don't spell it wrong. Be very careful. Okay? And you're going to search for the course name over here. Okay? And then you have to make sure you enable the location service of your mobile device. You just make sure you do that. And next, Tuesday, Thursday, let's do some informal attendance taking just for testing. Next Tuesday and Thursday. And then the week after, we'll start the normal thing. Okay? Just for next week. Let's make sure you know how it works. Should be quite straightforward. Right? Shouldn't be any surprise. Any question about bonus opportunity here? And as I mentioned earlier in the syllabus, I will also try to give you guys maybe some chance to maybe give me some midterm evaluation, which is completely anonymous. And also the final course evaluation will also be anonymous. So just to get you participate, making the course better for later. So that will also be a bonus for that. If you reach certain response rate. Yeah.
I prefer the one by Macmillan New Ventures.
Yeah, you want to choose the student version, the free version. You don't need to pay for that, okay? And then once you get the app, search for the course, enroll, you should be done, okay? All right, let me move on to the next part, okay? Semester calendar, all right? So that's also important. And I also show you can download the standalone version PDF from the website, from the study site. You can download it, but let me go over some important stuff with you from there. Okay, let me go to calendar over here. Okay. So we are here today for lecture number 1. The last lecture will be this particular one, 24, before the study day. 13 weeks, okay, 24 lectures. And what about our test? Your very first test before the before the reading week will be programming test number 1. October 9th. And that one there is mainly going to cover lab number 1, what you have learned in the tutorial on Rodin. I might extend it with some coverage of some lectures, but I'll let you know at least 1 week beforehand so you will know what to expect. That'll be before the reading week, so you do have enough time to really get yourself used to the Rodin, its syntax, and also the mathematical ideas. So please make sure you do that. After the reading week, we got written test number 1, October 23rd. And we also got programming test number 2, November 6th. We got written test number 2, November 20th. So these tests are primarily not cumulative. So for example, let's say if I got, written test number 2. What is it going to cover, right? Written test number 2. It's going to cover basically starting from just the lecture before written test number 1, because in written test number 1, we don't cover lecture 12. It's too close. It's not fair, right? So starting from here, that's it, right? Not here. This will be left for the exam, all right? Something like that. But before the exam, before each test, again, I will confirm exactly what I'm going to cover. So don't worry. I'm just talking about principle. Yeah, we got lab 1, 2, 3, 4, and 5. All right, good. Any question about the semester calendar here? Anything that's not clear? All right, anything that you think that's maybe missing? Good. Yeah, download the PDF. I think that's going to be very handy. If there's any change to the calendar, I'll definitely let you know. So you can re-download the updated version. But it should be rather stable, I believe. Should be, yeah. Yeah, if you find that you really have any potential conflict, which you shouldn't have, with the lab test over here, in that case, since the dates are already announced, please make some prior arrangement for that so you don't miss it. Okay. All right, let me go back to syllabus over here. Okay, coverage to talk about, and also for weekly schedule. Yeah, the lab session back to back. You can go to any one of them or both of them for Q&A. And starting from next Wednesday, we also got TA to monitor the lab. I think, I don't know. So whenever I can be there, I'll be there as much as possible. And then we got office hour, right? I mentioned 3 to 4, Monday, Tuesday, Thursday, right? Just remember, Monday, I'm not on campus in principle. So Zoom, I'll be there. And the lecture. Okay. All right, and the tentative topics, don't worry. I think most likely we're going to cover a review on math, predicate, sets, relations, and also some bridge control. It's going to be a fun study case, like a case study to have throughout the term. We're going to talk about it in various refinement steps and conclude on that, most likely. I might assign some optional case study for you on the file transfer protocol. We'll see how that's going to go. All right, that's about the end of the syllabus. Is there anything you guys would like me to elaborate about the course policy? Anything that's unclear? Yes? You mean how do I take attendance? Yeah, so I'll show you exactly when we get there. But basically, so let's say once we start doing it, the real thing, I'll randomly choose any class, right? Doesn't need to be Tuesday, doesn't need to be Thursday, doesn't need to be every class, right? I'll just randomly choose it. Let's say if I say, okay guys, let's now take attendance now. So please have your mobile phone ready. You should have it ready. Usually we have a few minutes window for everybody to check in, take attendance, and once I close it, that's it. Okay, that's basically what's going to happen. I wouldn't just take it right in the beginning. Some people might still be arriving. I may not take it at the end. I might take it somewhere in the middle. Also, okay. Yeah, good. And if I see anybody just leave after taking attendance, I will cancel them on the attendance, just to be fair to everybody, right? We'll see. Hopefully, we wouldn't do that. Yes, question.
We're doing a programming test, right?
Yes.
How would that work? Because you said that if we're gonna.
Yeah. So I think a programming test, it's going to be on Rodin. You will be given instruction in a very similar style, like in lab number 1 and 2, which you will see pretty soon. So don't worry too much. I think once we get to programming test 1, about 1 week or 10 days before the test, I'll give you guys some guidance to how to get prepared for that. Yeah.
You wrote E-class right next.
Yes.
So will it be done on E-class?
Yes, of course. Written test is going to be done on E-class, multiple choice based. It's like a quiz. Okay. So the question will be randomized, and I wouldn't say how many percentage, but primarily it will be multiple choice. Okay. There might be some questions where you might be asked to type something, to enter. Yeah, good. Good. And the multiple choice, for your information, you guys have done, E-class a lot, I'm pretty sure. The correct answer might be a single one. It might be multiple answers. And of course, E-class does have a mechanism to say if you got multiple answers, let's say you got 3 correct answers, you somehow chose only 2. You might get some deduction on the marks, right? I didn't invent the scheme. E-class does. Right? I will also give you some precise calculation mechanism so you can see. Okay? Okay, good. If no more question, let me go back to the slide to see what else to say. And then we can very smoothly move to a little bit of introduction to the course very soon. Okay? Let me just go back to the slides. Okay, maybe just some slides, and then we can take a very short break, and then we can move on a little bit more. Okay? So, software engineer. You guys are in software engineering, so you want to become a software engineer. So what we really want you to do is you're given problems that are actually specified. Well, I'm talking more about programming over here. But when you are given a programming problems, you should be able to develop your code by just having the API and maybe some Java JUnit test cases to figure out what to develop. You don't really need to say, I want to have the LED light and fidget board set up for me as well to test. You don't need to, right? And regression testing, I'm pretty sure you guys know about. I think for Rodin as well, you can also do regression testing. Let's say you build up your machine for the bank. Now I'd say make one little change to the model. For example, change the guard or change the invariance. Is it going to cause your model, which used to be completely provable, suddenly unprovable? Right? That's also like a regression testing. You want to make sure every time you make a change to your formal model, all the proof obligation, everything you have already proved already should still be provable. Right? It's like whenever you make a change to your software, whatever JUnit test cases that used to pass and give you a green bar, you should still get a green bar. Right? That's kind of the analogy here. That's why I'm mentioning here. Thinking abstractly, definitely applicable to this course because we're thinking more not in coding, but in math. And you guys used to hear that people say 2011, well, it's now renamed to 2101, right? But you guys took it when it was 2011, right? Sorry, I'm still getting confused about this name. Yeah, but anyway, 2101. This course, people say it's good for interview. To be honest with you, I will argue 3342 is also pretty nice for preparing for interview because you're thinking not in terms of the classes or objects, you're thinking in terms of machines. In some way, our computer, the way it works, is really like an abstract state machine. That's something we'll elaborate also more when we talk about the course material. Okay? Yeah, so let's say if you go to the interview of some tech company, they want you to somehow give you them some algorithmic sketch about how things work. So what we learn in this course can also be useful, helping you think abstractly. You don't really always think about in terms of pointers or objects. Thinking about mathematical construct is also useful in some context. Okay. All right, some general tips, about studying university. Well, you can read it, right? I just say things got to click. So working hard is very much appreciated, but sometimes may not be so enough, right? So you want to make sure things click on you for the math, right? And hard work is important. Please make sure you master the ground stuff, which means whatever basic stuff we talk about in the lecture, the examples, and you also want to stay on top of what's being taught. You want to always keep reflecting on things, keeping connecting the dots. All right, go beyond the lecture. You may want to look for some extra resources yourself, and be curious about why things work and why things don't work. Why would this theorem prove in this context? But as soon as I change something here, suddenly the theorem will start to prove, right? Something like that. Always reflect. And final thing, easy to say, but difficult to do, even including myself when I was a student. Be happy to do some work, may not be associated with marks. All right? Maybe some optional exercises, not directly relevant to your test, but can help you understand the course material. Be happy to do them if you have time. All right, finally, I'll share a picture over here about success, right? Just very general. I kind of personally like this picture a lot, right? Hard work, persistence, late nights. That could be a little bit biased, right? Could be early mornings. You may not be a late night person. Could be early mornings. Rejection, sacrifices, discipline, criticism, doubts, failure, risks, right? Everything, right? About success. Anyway. Any question? I think I'm done with the general stuff about the course. For course policy, anything about the course syllabus, I think we've gone through all of them. Any question? Okay, I would suggest we take maybe only a 3 minutes break. It's now about 6:28. Let's come back about 6:29, about 6:32. 3 minutes, stretch your legs and don't go too far. And then when you come back, we can do another 15 minutes or so, introduction, and then we're done. Okay, take a short break. 3 minutes. Question? Give me one moment, sorry. Okay, I think we got about 10 or 15 minutes. I would like to just go over a little bit more background about this course. And then there will be a last bit. I think it would be nice to talk about more thoroughly, maybe next Tuesday. But let's cover something, right? Let's not waste time. I think that there was a good question asked by one of your classmates. It is important. For your programming test, and also for your written test, all 4 of them should be completed in person. Even though your written test will be done in e-class, you cannot do it remotely. If you try, you will get 0. So please make sure you come at the minimum number of times you should show up to the scheduled lab session you are enrolled will be 4 times, not 2. Okay, please. Make sure you understand that, and let's now go over some background. Just a little bit, not too much. Nothing technical, but it's something that's good to know. All right, we're going to want to understand what's really a safety critical system. That's really the target of this course. And there's another term called mission critical system. That's exactly the title of the course you're enrolled into study, I guess next term, right? As a prerequisite. The prerequisite for that course is this one. Okay? So we'll do a little bit of terminology clarification about what's really safety critical versus mission critical. We'll do that. And then, since you guys are going to be a software engineer once you get an engineering degree, it will be important to be aware of the code of ethics for professional engineers. I'm going to go over some important points together with you, explain its rationale. There will be a link by PEO. Do you know what PEO is? Professional Engineers Ontario. So every province in Canada, they also got their Professional Engineers Association. So they are responsible for issuing licenses for engineers. For example, myself, in order for me to be qualified to teach you guys, I need to be licensed as well. Okay, so it's quite a useful concept to really be aware of. And we're going to talk about what a formal method is. You may not have heard about this term, but this term is really getting more and more practical, in the industry as well. Whenever you got some software-intensive system developed, how can you certify the system in a formal way, mathematical way? And we're going to use formal method. And let me write it down for you. I think that's important. Whenever you hear about the term, I'll get to this distinction a little bit later. Let me get a new page. So we're going to talk about formal methods. And very easy to understand its meaning. Formal really means mathematical. And usually when we talk about mathematical, we really talk about discrete math as opposed to continuous math. Not really calculus. We don't really do that. Okay? Discrete math. And the reason for being discrete rather than continuous is simple. If you want to verify a software system, we know that computer system is discrete, not continuous, right? 0 and 1. So that's why discrete math will be the nice fit. Computer system is discrete. Zeros and ones. Binary. Okay? Formal methods. And there are many branches about formal method you can learn about. Even it's a big research area if you're interested later if you do graduate school. These days, of course, in my years, back in maybe 2006 when I was doing my PhD, there was no such thing about, well, there was, but not as popular, doing research in machine learning or data science. At that point, formal method is a very popular area for people to know how they can apply mathematics practically to verify system. I think it's still valid, it's still active. So if you're interested, maybe later for your further study, you can also consider. Okay? It's very useful, very practical area. So there are basically 2 courses you will learn about formal methods in the SE program. So 3342 this term, also 4315. This is mission critical system. Okay, and I'm just going to mention some keywords to you, and then we're going to do more elaboration later. And for 3342, we apply the formal method called theorem proving. Well, obviously, it's about proving theorems, right? It's kind of basically the literal meaning. And in this way, you're going to do some deduction. That's basically what we're going to do a lot later when we see the case study. Basically, you're going to get things like, you're going to get variables, also axioms. We'll review what they are, don't worry, I'll just mention them. And also you might get some invariants. I should also mention we also got some constants. Once you get all these, you're going to ask mathematically, do they entail implication, some properties? And the way we do that is by using deduction, which is maybe what you did in 1090. So you're going to say, I'm going to transform from one predicate gradually to another, ultimately to another. That's true. Right? That's how we prove things. Don't worry, everything will be reviewed and will be done extensively. That's theorem proving. And the way you do theorem proving in Rodin is kind of interesting. We'll have a small lab for you to do some very simple exercises for you to get some feel. Just to do the theorem proving in general is a very sophisticated task. And that's not something we would expect you to completely master in one single term. That would not be fair. But I think that if we set a context to be very restricted, there's something you can do to get the idea. That's what we will do. Possibly in lab number 4. Okay? You can look forward to it. And very quickly about, another thing to mention. Theorem proving here, usually the process is manual. Meaning that you have to type in all the constant, axiom, whatever into the rodent, and then when you want to prove something, you may have to interact with the prover. Interaction. What do I mean interact? You have to somehow do some mouse clicking on the rodent tool to say, this is how I would like to prove my theorems. I want to follow a certain path. Right? You will see that later. Manual, that means you're going to have some manual interaction with the prover. All right? That'll be good for now. What about mission critical system? We're going to do, also we want to do formal method. We're going to do it in a slightly different way, which might seem to be more appealing to many users. Okay? Basically, what we said about theorem proving, apparently the biggest disadvantage will be is manual. So for an engineer who may not be so mathematically heavy, they may not be so familiar with the tool or about the process of doing natural deduction, they may not like this approach. They got to interact with the theorem prover so much that might simply go for the wrong path. In 4315, there's another approach, which is called model checking. I'll mention that first, and I'll give you some intuition. Well, the literal meaning simply means you get a model and check it automatically. The idea is like this. We have a tool called model checker. You can think about the model checker is like a software. It's simply like a black box. Okay? What you pass over here is a model for your system, and also some properties you would like to prove. You don't know whether the property should be true or not for your model. And now, the tool over here is going to give you 3 outcomes. Can you guys imagine what kind of 3 outcomes is it going to give to you? 3. Anybody? 3 outcomes. 3 possible answers. Well, think it this way. If I give you a predicate, I say now prove what, well, I almost say to you the answer. So now let's say you got a predicate, I want you to prove it. What can be the possible outcome, you tell me? Please. True or false? That's very good. Either I can prove it or I cannot prove it. I'll write it down first. Either the tool is going to tell you, yes, it is proved. Or no, it's somehow not proved. And what's really good about model checker is it's going to give you some counter example to show you this is the scenario where your theorem is not going to be true. That's nice. Very good feedback. All right? This tells you where your system might go wrong, which doesn't satisfy the desired property. But remember I said there are 3 possible outcomes, right? Can you imagine what a third might be? Not really undefined, maybe getting the right track. Not undefined. That's not the word I'm looking for. Not undefined. Everything's defined, right? When I define a model, when I define a property, they have very clear meaning, unambiguous. Nothing is undefined. Cannot be calculated. Getting a little bit closer. Does not exist. Not really. Things exist over here. No. Not really. Well, nothing's null, right? Everything's concrete over here, right? Okay, I'll tell you. Yeah, maybe one more.
Valid property or property that's being present is invalid?
No, actually, everything is syntactically valid, right? So we already said either you can tell you, yes, I can prove the property system, or I can show you some counterexample. But there's a third possibility. Cannot be proved. It's similar. Okay, yeah, okay, I'll leave that answer for now. Okay, yes, one more.
You mean it shall be proved and not proved?
There's no way between. Either you can prove it or you cannot prove it. Okay? Yeah, okay. Maybe one more. You want to speak up? Yeah, go ahead. Not enough evidence? Not exactly, right? Because the prover is trying its best, right? Okay. Actually, in some way, I'll put it more informally. The system is too large for the tool to conclude. Or another way to put it, the tool does not halt, does not terminate on the problem. So there is a well-known problem for formal verification called state explosion. Okay? I'll just mention that over here. So this is really something called state explosion. I can give you some very quick intuition. And when you get to the 4315 next semester, I think your professor is going to maybe elaborate this a little bit more. Okay? Let's say this. If I tell you this, my system actually got x, which is an integer, that's in the range, let me just put set membership. It's in the range of 1 to 10. Let's start with the simplest one. Now, how many possible states do I have for this particular system? 10. Easy, right? Let me make it slightly more complicated. I got another variable here. How about 1 to 5? Now, how many possible states do I have? Don't tell me 15. What is that? Should be multiple together, right? That's combinatorial thing we are doing. 50, right? Because for 1 here, it can be combined with 1, 2, 3, 4, 5. For 2 here, it can be 1, 2, 3, 4, 5. So it's 10 times 5. Now, what does that mean? Realistically, your system might have 100 variables. Each one of them may be integer, which is 2 to the 32 bits. Oh, how many combinations is that? It could be a string. It could be Boolean, maybe only 2 possibilities. But if you multiply all the possible outcomes there, we're going to get an explosion. That's what we call a state explosion. What the model checking approach does, intuitively, is try to explore every possible combination of the variables, what we call the states, in your system, to see does every system there satisfy the property. But now the problem is, if the number of combinations for your variable is simply too big, there's no way for the tool to really halt, terminate, and decide. So that's why this is a third possibility. And I can tell you that the third possibility here is not uncommon. It's quite common. Because once you get to be very realistic system, it's just too big. So that's why model checking in some cases are not still exactly practical. But it's good to know. All right, that's the intuition I would like you to have. All right, so these are the 2 formal methods that we're going to teach you in the SE program. But for this semester, only 3342. All right, good. Oh, 6:50, right? How about this? Let me just finish that particular slide and I'll let you go. Just give me 1 minute. I know I'm almost over time, which is not good. What the formal method is, and then we're going to talk about verification versus validation. Is also good to know. And then model-based system development. Okay, so thank you so much. Next time we're going to start from go a little bit more into detail for these, and then we're going to continue the math review. Thank you. See you next week.